Hello everyone, this is Namita Rana here, your chemistry educator, and today we will be learning about a very important topic of organic chemistry, that is your esterification reaction. So let's begin. Now the word suggests esterification. Ester is coming, right? What do you mean by ester? Ester is actually R, C, double bond, O, and R dash. Okay. Now this is actually a derivative of carboxylic acid. Everyone knows what is carboxylic acid. Now this OH is replaced by a OR dash group. Now in simple language, esterification is a reaction in which ester is formed from carboxylic acid and alcohol. So by using two reagents, that is our carboxylic acid, RCOOH, and another one as ROH, which is your alcohol. This is your acidic part, and alcohol part will give you R, C, double bond, O, and R. For the ease of reaction, let me indicate this alcohol by a R dash group, which may or which may not be different from this R, right? Now, second important point about this reaction is it is reversible in nature. And reagent used in this reaction is a concentrated sulfuric acid, which actually helps for the forward of the reaction. That is, it is helping for the equilibrium to shift towards right side. Now, if I consider the mechanism for this reaction, you will see first this acidic. Now there are two acids which are used in this reaction. One is organic acid and another one is mineral acid. Organic acid is the acid in which there is C group. So this is your carboxylic acid. In presence of concentrated sulfuric acid, that is H2SO4, it gets protonated. Right. Now this acid group will obviously release H positive and the leftover part is HSO4 negative. Now this HSO4 negative is known as conjugate base, correct? This H positive is now going to connect on this oxygen atom of the carboxylic group. Remember, there are two oxygen atoms in this group. This also, and another one is this. But the acidic part of the carboxylic acid is going to attack the O of the carbonyl. So it gets protonated to give us double bond O was already here and a H positive ion, making this oxygen as positive, right? As soon as this reagent is formed, it is attacked by the another reactant, which is your alcohol part. Also, this double bond will shift here. Can you tell me why? Easy, because oxygen being more electronegative cannot bear this positive charge on it. So pi electron cloud from this double bond, which is between carbonyl, will shift towards the oxygen atom, forming what you are going to get are what we will be getting this group as OH and OH group. Now, as the electron density between these two atoms, which is oxygen and carbon, is shifted towards oxygen, this carbon will acquire a partial positive charge for momentary, right? At that time, this alcohol, which is having lone pairs, will get connected to this carbon. So basically, I can write for this partial bond, we have attached a alcohol group by oxygen atom on this, which will give you this type of intermediate, which is the transition state. This is the transition state which is present in esterification reaction. Now, the most important step of this reaction. Just look at this carefully. What is going to happen here is this oxygen atom bears a positive charge. Everyone knows oxygen being more electronegative cannot bear a positive charge. So this hydrogen get transferred to this oxygen. This is intramolecular, what do you call it? Intramolecular proton transfer. Consider this step, please. R, you will get R, C, OH was already here. Now this oxygen, H was already here. This H has been shifted towards this oxygen, forming this oxygen as positive charge and this group as this. Now, what you will see, dehydration. Can you tell me the reason of dehydration? Obviously the same, that oxygen being more electronegative cannot bear a positive charge on it. So it is going to eliminate this water molecule. In this process, this carbon will acquire some kind of positive charge, but oxygen is already here, which is having a lone pair, right? So we are going to get R, C, O, R dash, double bond, O, H and positive. Now, as this acid H2SO4 has been used as in catalyst, this is used as in catalyst, this conjugate base is in search of H positive ion because we know catalyst cannot be consumed in the reaction. It has to be reformed. So, as soon as this species is formed, we see oxygen being more electronegative, cannot bear a positive charge. Now, this has to be removed, which is taken by this conjugate base. So, in presence of HSO4 negative, what you will get is R group, then C double bond O, OR dash group, and finally H2SO4 reappears in the mechanism. So, the product formed is a ester group. Correct? I hope you got it. Thank you so much.